Hey guys, in this video we are going to be talking about graphing quadratics in vertex form. So as we saw in the last video, this is what vertex form looks like. So just as a reminder, our three forms are standard form, which we talked about in the last video, vertex form, and factored form. So in standard form, we talked about how the y-intercept is always going to be this number here. That was the obvious thing from this form. In vertex form, we can find the vertex really easily. That's why we call it vertex form. So remember in the last video, in order to find the vertex, which again is this maximum or minimum point, depending on which way your parabola is facing. So in this case, it would be a minimum, right? So from standard form, we had to say, okay, x equals negative b over 2a, find that number, and then plug it into this equation, and that gave us our vertex in standard form. In vertex form, we can just say, oh, the vertex is negative h, in other words, the opposite of this number here. So if this is, say, positive 2, then the x-coordinate of the vertex would be negative 2. And then if this is negative 2, then the x-coordinate of the vertex would be positive 2. So it's the opposite sign of this. And then the y-coordinate is just k, whatever this number is. So in this case, the vertex would be 4, right? This is negative 4, so the vertex would be positive 4, positive 5. So that's why we call it vertex form, because we can just read the vertex right off of it. All right, so then the next thing we would do, we could plot our vertex. So our vertex is at 4, 5, 4, 5. And just like last time, we want to get some points on either side of our vertex. So our vertex is here at 4. So when we want to find some points that are on either side of 4. So I'm going to find 2, 3, 4, 5, and 6 are the x values that I'm going to use. So 2, 3, 4, 5, and 6. 4 I already know. And if you want to prove to yourself this is true, if you plug in 4 here, 4 minus 4 is 0. So 0 squared is still 0. 0 times 2 is still 0. So this whole thing goes away and you end up with 5. That's why this works. All right, now we're going to plug in 3. Actually, I'm going to plug in 5 because that way I can deal with positive numbers instead of negative numbers. So I'm going to plug in 5. 5 and 3, if you remember from the last video, should give you the same answer. 5 and 3 should give you the same answer. And if you don't believe me, you can plug in both and see. But because they're on either side of the vertex and parabolas are always symmetrical, they should give you the same answer. So I'm going to plug in 5. So I'm going to give myself some room over here. And I'm going to plug in 5. So 2 times 5 minus 4 squared plus 5. 5 minus 4 is 1. 1 squared is still 1. 2 times 1 is 2. 2 plus 5 is 7. So when I plugged in 5, I got 7. So 3 is also going to be 7, because again, if they're the same distance away from the vertex, they're going to have the same y value. And these are all 1 apart, so these will have the same value. 2 and 6 will also have the same value. So I'm going to plug in 6. So let me erase again so that I have room. And I'm going to plug in 6. So 2, 6 minus 4 squared plus 5. 6 minus 4 is 2. 2 squared is 4. 2 times 4 is 8. 8 plus 5 is 13. So 13 is my answer. And because it's symmetrical, if I plugged in 2, I would also get 13. The reason for this is, remember we plugged in 5, we got 5 minus 4 is 1. Well, 3 minus 4 is negative 1. Negative 1 squared is positive 1, so you end up with the same thing. Same with 2 and 6. When I plugged in 6, I got 6 minus 4 is positive 2. Well, 2 minus 4 is negative 2. Negative 2 squared is the same thing as positive 2 squared. So I end up with the same answer. So let's go ahead and plug in these points. So I have 2, 13. So I go over here to 2. And 13 is not on the graph. So it would be up here somewhere. Not too worried about that. 5 and 7. 3 and 7. So 3, I'm going to go up to 7. That's that point there. 4, 5, I already have. 5, 7 is here. And then 6, 13, again, is not really going to fit on the graph. All right, so we're going to move let's go ahead and move this point to here. Oh no, it's moving my dot. That dot was at 4, 5, which is here. I don't know why it moved my dot. That's really sad. It was here at 4, 5. So this is what my graph looks like. You can see it goes through these 2 points just like I wanted it, just like I expected it to. So that's good. Go ahead and check that. All right, I'm gonna do, well, I mean, it's pretty much exactly the same. So each one, the location of the vertex will be different. So the numbers that you're choosing will be different, but the system of how you're going to do it is exactly the same. So like for this one, the vertex would be at positive 6, positive 1. So I would be over here at positive 6, 1. So for my x values, I would choose 4, 5, 6, 7, and 8 because I always want that vertex to be in the middle. All right, hopefully that helps. Let me know if you have any questions, and I'll see you in the next video.